Welcome back to another video with me, Mr. Amaro. This week, instead of going over stuff in the packet, I really want to teach you a lesson about probability. And to do that, we are going to play a game. Well, I'm going to play a game, and you guys get to watch. We're going to play darts. So before we can play, I really want to explain the math about it. Okay, so there's two types of probability that we have. We have theoretical probability and experimental probability. So theoretical probability is the likelihood that something will occur and is found by taking the number of desired outcomes over the total number of possible outcomes. I'll explain that more when we get to the board. An experimental probability is the ratio of the number of times an event occurs to the total number of trials or times that the activity is performed. And it is found by taking the number of times an outcome occurs and you put a line under it, and it's over the total number of outcomes or trials. So let's try it out. So for this experiment, it's going to be pretty simple. You just have to hit the target, anywhere on the target, and it counts as a good try, a trial. With only one color on there, the probability or the theoretical probability of getting on the blue is 1 out of 1 because there's one outcome possible, right? So it's 100%. Now, experimental probability, we haven't done any trials yet, so we have no data to make an experimental probability from. So I'm going to bring some volunteers in, and they are going to do the experiment. Here we go.
Dart.
Okay, so now we have done the experiment, and if we look at these results, all 4 of the darts made it onto the blue. So our experimental probability was 4 out of 4, or 100% of the blue. All right, this time I changed up the board to where it has half of it is an E and half of it is an R. So the theoretical probability of each of these would be 1, because there's one way to get an E, one way to get an R, and that's out of 2 possible outcomes. So that's 1 over 2 for theoretical probability. Now, once again, we don't know what the experimental probability will be because we haven't done any trials. So let's bring in the volunteers. All right, so after my volunteers threw the darts, let's look at our results. We have 3 in the E section and 1 in the R section. So our experimental probability would look like this. So I made a chart with E and R and wrote down the results. E had 3, R had 1, and on to the right side over here I have our probability of E was 3 out of 4. The 4 comes from there being 4 trials. And for the R, it was 1 out of 4, being 1 of the 4 darts landed on the letter R. On our first experiment, when we had just blue, our theoretical and our experimental probabilities were the same. But this time, our theoretical and experimental probabilities are different. Remember, theoretical probability was 1/2 for both E and R, and then our experimental probability was 3/4 and 1/4. For this experiment, I cut up the board a little differently. This time we have V, R, E, dog, and Mr. Now, there are 5 different pieces, but that doesn't mean that they all have the same probability because dog and Mr. are smaller pieces than R, V, and E. So let's do some math and try to figure this out. To figure out the theoretical probabilities, I'm going to make a chart that has the list of outcomes and their probabilities. So for the letter V, how much of the target is it covering up? 1/4. The letter V is covering up 1/4 of the whole target, so its probability is 1 out of 4. The same can be said for the letters R and E. So each of them has a probability, a theoretical probability of 1/4. Now, when we look at dog and Mr., those are smaller pieces. Together they form 1/4, but half of that would be 1/8. So dog and Mr. have a theoretical probability of 1/8. Because this experiment has so many different possible outcomes, I'm going to have our volunteers do more than just 4 trials. One more. Keep going. Try to hit the board.
Why inside the...
Go, 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 go. Reece is having a little trouble. I'm going to take over. After I looked at the results, I wrote them down, and this is what they were. V had 3, R had 3, E had 3, dog had 1, and Mr. had 2. So now, in order for me to figure out the experimental probability, I need to figure out the total number of trials. So 3 plus 3 plus 3 plus 1 plus 2 is 12. Knowing these results and knowing how many outcomes there were total, I can figure out the experimental probability of each outcome. So V was 3 out of 12, R was 3 out of 12, E was 3 out of 12, dog was 1 out of 12, and Mr. was 2 out of 12. Now, with experimental probability, like with these results, I would want to reduce that number. All of the 3/12 can be reduced to 1/4. 1/12 cannot be reduced, but 2/12 can be reduced to 1/6. So now I have my experimental probabilities for each of these outcomes. So here I have the theoretical probabilities and the experimental probabilities both on the same screen so you can see and easily compare. V was consistent with 1/4. R was consistent with 1/4. E was consistent with 1/4. Dog was different. Our theoretical probability was high in comparison to our results. And then Mr. was very close, but Mr. was higher in the experimental than it was in the theoretical. So when you are doing your math in your state assessments and your Mathia and iReady, they'll give you questions about theoretical and experimental probability. And I just wanted you guys to be ready. And now you know how to find theoretical and experimental probability. All right, thank you guys for watching this video, and thank you to my 2 volunteers. And last but not least, do not forget to do your iReady and Mathia work. I know it's not that fun, but you need to do it so you'll be ready for next year. Subscribe.
Make sure to like and subscribe.